welcome to this lecture. In this lecture, let us solve three important problems. So, let's look at the first problem given here. A helium sample is initially contained in a 1 liter cylinder at a pressure 1 atmosphere. The gas undergoes an expansion where its volume increases to 3 liters with the pressure directly proportional to the volume throughout the process. Calculate the work done on the gas during this expansion. So, in this question or in any question given, whenever one quantity is proportional to the other quantity, for example, pressure is proportional to volume, in that case, we can remove proportionality and put proportionality constant like this. So now initially we are given the pressure and volume. So from that we can calculate K P1 by P1 for any set of parameters. This will valid. So K here is P1 is given as a 1 atmosphere. We have to convert into SI units. 1 atmosphere is 1.013 into 10 power 5 Pascal divided by volume is given as 1 liter. So 1 liter is nothing but 0.001 meter cube. So this will give us 1.013 into 10 power 8. So this is the K value. K equal to we have to calculate the work done on the gas during this expansion. So work done on the gas or on the system is equal to minus PdV. So for example, when work is done on the system or gas, it will lead to compression. So compression will lead to dV being negative. Negative of negative will be positive. So in that case, if we get positive, that implies work is done on the system. And if we get negative, then work is done by the system. So minus PdV and P is equal to kV. So I'm writing. So work done will be is equal to integral dw, which is integral minus pdv, which is minus kv dv, and from volume initial to volume final. So when we do this integral, we get k v square by 2 minus I am taking outside volume initial to volume final. So here let us write volume. Sorry, work done is equal to minus k by 2. K is 1.013 into 10 power 8 by 2, and Vf square minus Vi square. Vf square is 3 square, that is 9, minus Vi square is 1 square, which is 1, and so it is liters. We have to convert into mm, SI units, that is meter cube, which is 0.001, and we have to square it. So this will be 10 power minus 3 whole square is 10 power minus 6. 9 minus 1, 8 and 4. So we get minus 1.013 into 100 into 4. So that many joules. I think it will be 1.013 when we do 4 times 4.052 into 100. So minus 405.2 joule. Check if this calculation is correct. So we got negative in the answer. So here we got minus sign. In the question we have said, asked calculate the work done on the gas or work done on the system. And whenever we have to calculate work done on the system, we have to go with the dW is equal to minus PdV. And that's very obvious because if work is done on the system, it will be compression, then dV will be negative, minus of minus will be positive. So as work done is positive, work is done on the system. But in this case, after calculating, we got negative. So work is done by the system. Work is done by the system. That means gas by expanding, it did work on the surroundings. How much work it did? It did 405.2 joules. In this case, work is done uh, by the system. Sorry, by the system. Now let's look at the second problem. Given is a mercury thermometer which contains mercury with a coefficient of volume expansion 1.82 into 10 power minus 4 per Kelvin. Initially, the mercury occupies a volume of 500 centimeter cube at a temperature of 25 degrees Celsius. If the temperature rises to 75 degrees Celsius, calculate the change in volume of the mercury due to thermal expansion and the final volume after expansion. So, here we need to answer two things, the change in volume and final volume after expansion. So, coefficient of volume expansion, that is beta, coefficient of volume expansion, and this is given as 1.82 into 10 power minus 4 per Kelvin. And we know that beta equal to change in volume by reference volume or initial volume. V by T. So this gives rise to um, see change in temperature here. So change in temperature in Celsius or Kelvin is same. So here 75 T2 minus T1 is 75 minus 25, which is 50. Also we have given initial volume. I'm just writing here. So this initial volume is 500 centimeter cube, and this change in temperature is 50 Kelvin or 50 degrees Celsius. So here this will lead to delta V by V times delta T equal to 1.82 into 10 power minus 4 per Kelvin. So from this, let's calculate delta V. Delta V is equal to initial volume. This V is 500 centimeter cube. So 500 times delta T is 50 times 1.82 into 10 power minus 4. So here we have two zeros, 10 power 3, and so we got 10 power minus 1, and here 25, basically 2.5 into 1.82. So let's calculate this. So this is like 4.55 centimeter cube. You also cross check the result, and so V final after expansion will be is equal to Vi plus 4.55. So that will be 504.55 centimeter cube will be the final. So this is our first answer, change in volume and the final volume. So this is of mercury thermometer. Next, go to another problem. Okay, here we are asked to calculate the mass of 1 mole of nitrogen gas. So, um, 1 mole of nitrogen, 1 mole of N2 consists 2 moles of N atoms. And we know that the atomic mass of nitrogen, atomic mass of nitrogen is equal to nitrogen atom equal to 14 grams per 1 mole. 14 grams per 1 mole. So in 1 mole of N2 gas, there are 2 moles of nitrogen atoms because each nitrogen molecule consists of 2 atoms. So that makes it 2 moles of nitrogen atoms. Hence, the mass of 1 mole of nitrogen gas, this would be uh, 2 times 14, that will give 28 grams. So this is how we calculate using atomic. If there are different molecules in the different atoms in the molecule, then we have to consider atomic mass of each atom, and calculate based on the number of moles. Now see this. So here I'm giving three assignment problems. Uh, Please solve these or write answers in the comments. So these are quite important ones. Thank you so much for watching, and please subscribe to get more concepts and also sessions on problem solving.